In this video, we will learn about receiver operating characteristics. Receiver operating characteristics is otherwise known as ROC in short. Well, this is used to assess the predictive power of a binary classifier. We know that binary classifier is a model that classifies, good or bad, or loyal, disloyal, or 1 and 0, two values. Binary classifier is a model that classifies between two values. Logistic regression is one of the most popular binary classifier model. We assess the predictive power of logistic regression using ROC. Well, this comes from signal theory, but nowadays heavily used in the analytics industry. What it does is that it plots the graph between true positive rate, or known as TPR, versus the false positive rate, or FPR, at different cutoff probability level. So three things we will learn: what is TPR, true positive rate, and what is FPR, false positive rate, and then what is a cutoff probability level. Okay, so let's study in the context of logistic regression. For simplicity, let's take there are two values, 1 and 0. 1 is good customer and 0 is bad customer. Okay, it can be anything though. So what is true positive? Good customers classified as good customer. Okay, customer A is actually a good customer in our data set, and the model also says that it's a good customer. Then it's a true positive. We also call it as sensitivity. Okay, because that's very important for us, and if a model is able to do that, we benefit from it, right? Benefit from the model. So that's gives us profit. Then what is false positive? Bad customers are classified as good customers. The model classify the bad customer as a good customer. That's very bad, right? It gives us it's very problematic for us, and which produces loss for us, something that is unexpected, right? So the trade-off between true positive and false positive is what is seen in ROC. So we want more true positives and less number of false positive, right? Okay, so what is TPR and FPR? TPR and FPR are derived from true positive and false positive. Okay, TPR is true positives by actual number of positives. Okay, and FPR is false positives by actual number of negatives. This will be more clear when we take an example later on. I define something known as specificity. Specificity is otherwise also known as true negative rate, is true negatives by actual negatives. Okay, false positive rate is equal to 1 minus specificity, and hence ROC is nothing but the plot between sensitivity versus 1 minus specificity. Sensitivity versus 1 minus specificity. Okay, and what we plot actually, we plot the cumulative values, cumulative probability values. Let's take an example. Okay, so first see what is a cutoff probability. In logistic regression, we save the probabilities values, right? If you're modeling for probability of a good customer, we get probability that a particular customer is good. It's so and so. Let's have a cutoff value as 0.5. We can have it for we can have it as any value, 0.1, 0.2, 0.3, depending on the convenience. So anyone having a probability score greater than 0.5 is a good customer. Less than that is a bad customer. Okay, and that is where we have fixed the cutoff probability. We can vary it. Okay, we can vary it though. In our example, there are 10 customers, 6 customers are good customers in our data and 4 customers are bad customers in our data, and we have built a model using this data. Okay, in reality though we will have too many observations, but for simplicity let's say we have only 10 observations, 6 good customers, 4 bad customers. And here is a matrix you can see on the screen where we have the actual versus the predicted values. In the columns you have the predicted, in the rows you have the actual. Okay, 1 and 0 and 1 and 0, both actual and predicted is there. The first box you can see, row 1 column 1, that's the true positive numbers. The actual is 1 and the predicted is also 1. How many cases are there? 5 cases are there. So that is the true positive case. Okay. Similarly, if we go to the next one, so the actual is 1 but the predicted is saying it's 0, right? So actual is 1 and predicted is 0. Similarly, if you go to the third one, here it is the actual is 0 but the predicted is 1. Okay, so actually is saying it's a bad customer but predicted model is saying that it's a good customer. So that's again a mismatch. The last one, bad customer and predicted as bad as well. So essentially we would expect that the diagonal matrix, the first one and the last one, fourth one, these to be maximized. The mismatches happen here and here. We want these two matrices to be having very small values. We want higher values in this and in this matrix. Okay. From here we will compute what is TPR and what is FPR. TPR, as I said, is true positive, which is 5, by actual number of positive in our data set. There are 6 positive or 6 ones in our data set, as I said in the beginning. So TPR is 5 by 6. What is FPR? False positive rate. False positive. Remember it correctly. False positive is nothing but somebody is not a bad customer but classified as a good customer. You can see here the predicted model says it's a 1, but the actual data says it's a bad customer. Okay, so bad customer has been classified as a good customer. How many cases are there? 1 case is there. Okay, so the FPR is 1 by 4. Why 4? 1 by 4 because there are 4 negatives. So your the false positive by total number of negatives. False positive number is 1 and total number of negatives or bad customers in our data set is 4, right? Total number of data set is 10, 6 are 1 and 4 are 0. So 1 by 4, so that is the FPR. If you keep on changing the cutoff probability, so at 0.5 we have these values. You change it to 0.6, you may not have this 5 here. Okay, probably you will have some other the total will always be 10. Okay, the total will always be 10, 5, 2, 2, 1, right? So you can count it as if you add them up you will get 10, right? So only the values will change with changing probability. And as you change the probability from 0.1 to say 0.99 and you keep on increasing that, you will see the TPR and FPR value gradually increasing in some order, okay, and having some relationship. You take their CDF or the cumulative distribution and then plot them, TPR versus the FPR, and we get the ROC curve. ROC curve looks like this. You have 1 minus specificity or the false positive rate in the x-axis and the sensitivity or the true positive rate in the y-axis. When we plot the probability, the cumulative probability, then we get the ROC curves. We have 2 to 3 ROC curves. So how does it help us in the logistic regression? Well, if you have 3 to 4 models, you keep on plotting these. You just plot these 3 models ROC on a single plot and see which one is performing better. How do you know which one is performing better? Let me show you. The third one is performing best here, followed by this one, and the one I am showing here is the least performing ROC. Why? Well, if you have a 45-degree line, okay, from the origin, having a 45-degree with the x-axis, that is that's the benchmark. Your ROC curve has to be left to that line. Okay, the more it is towards the y-axis or towards the uh, towards the left of that line, then the better is the model. Okay, so essentially what we are looking at is that the area under the curve. Okay, if you take the entire area under this particular curve, it is less, right, compared to the second curve. So the second curve, the entire area is more than the first one, and the third one is having highest area, right? This one. If you take the area and under this curve, it is the highest among these 3 curves. Area under the curve is otherwise known as C statistics. We know that more the C statistic, better is the model. Similarly, more the AUC or the area under the curve, better is the model. We compare ROC, and that's how we choose the best model out of several number of models. To summarize, ROC is a statistic or it's a plot basically, which is used to assess the logistic regression model. It's a plot between sensitivity versus 1 minus specificity, or in other words, true positive rate versus false positive rate. How can we draw it? We just need to have a matrix. We just need to see what is the true positive, false positive, and then we then get the TPR and FPR values, plot the cumulative probability to get ROC. Of course, if you are using a software, it will directly give it to you. We just need to know how to interpret it. We should ensure that the ROC or the curve that is having highest area under it is the best curve, or the model corresponding to that curve is the best model. Okay, if the AUC value or the C statistic is 0.5, then it's a baseless model, useless model. Okay, in that case, it will be just a 45-degree line to the x-axis. Okay, it should be more than a 0.5. The area under the curve can be maximum 1. Okay, it cannot be more than that, and most of the times it lies between 0.5 to 1. If it is more, better is the model. That's how we interpret ROC, or receiver operating character.